would like post the slides so then we can print those out. Oh, and take notes on it over video.
Yeah. All right, so half-life we're talking about today. Half-life is defined as exactly what you think it's defined as. Half-life is how long it takes for half the sample to go away. Okay, that is what half-life is. So if you have 100%, one half-life, you're going to have what percent left? After another half-life, what are you going to have left? 25. 25. It's half of it. Okay. Okay. So that's what it is. We're going to use this equation. So original sample, first half-life you have 50. Second half-life you have 25% or a fourth of it. Okay. Got a couple of the half-life equation is the same equation. Okay. T in 1/2. That's half-life. Okay. The time. This half-life's the time. ln2 over k. Okay. K is called the rate constant. I'm going to talk about that a whole lot more. Just know now that k is the rate constant. And now there's two different ways. If you put ln2 in the calculator, guess what you're going to get? 0.693. Okay. ln2 is 0.693. K is called the rate constant. We're going to use the half-life equation in with our other equation all the time. The rate constant is either given or you're going to find it via the other equation. So typically you're either going to have T1/2 or K is what you're going to have. Something right there, Mr. Thank you. Who are you? Who? Are you new? Oh, you're like Otis. That's who you. I don't recognize people without their mask on. It's really hard. I know. So I said you like Otis. Once you said who your name was, I knew who it was. Thank you. Thank you all. So K is the rate constant. This big equation. I might let me write that down somewhere for right now. That way you can have it for later. The rate of decay. Here's our other thing that we're going to use along with it. Okay. Rate of decay is how you can determine K. Okay. Or some other things. So it's ln of A over AO. Okay. Sometimes you instead of seeing A, it's AT. Okay. Now, when you take the AP exam, this equation is given to you as along with the half-life equation. But ln of A over AO equals negative KT. A is the amount remaining at some time. It is always the smaller amount. A is always the smaller amount. AO is the initial starting amount, is the larger amount. K is the rate constant, and T is time. And T is time. But ln of A over AO equals negative KT. It's the button on your calculator. It's the natural log. Okay? It should be right next to 7. What's it next to? Is it above 7? Oh.
Does it say minus KT?
No, negative KT. Negative KT. Equals negative KT. The reason why it's negative, okay? Anytime you do ln of a smaller number divided by a bigger number, it's going to be negative, okay? If your ln is not, when you solve it out, isn't negative, it's something wrong, okay? So your answer is always going to be positive, but that negative is in there to make sure that your answer is positive. But it is extremely, extremely important when you're looking for A or AO. We'll work some examples of this. We good? So let me stop sharing that screen and let me pull up some rate of decay questions. Only I don't have good examples on this. It's always the smaller one, yes, ma'am. Okay, so we're going to go to something new. Slideshow. Current slide. Let me make sure I'm sharing the correct screen. Stop. All right, so here's our examples of our first order reaction. This is everything we're going to do is be first order. You have to know that all radioactive decays are first order. That's really coming more in third quarter when we talk about kinetics, but if I can beat that in your brain now. So here's your question that you're going to have. Here's how it's going to be worded. Where is the thorium-231 undergoes beta decay to form protactinium-231 with a half-life of 25.5 hours. Find the rate constant for this process. Now, I would be confident that 2 other people in here would have something. Hey, what do I need to do to get my smart board working where I can write on it? Or is that no longer able? No. I don't have any pens, but they stopped working last year. So if you have a pen, would you bring me one or 4? Okay, I appreciate it. Thanks. I'm sure Nate's tired of dealing with Mr. Birdside's doing the thing. All right, so that's the question. Thorium-231 decays by beta decay to form protactinium-231 with a half-life of 25.5 hours. Find the rate constant for this process. Let me know when you have it all written down. I'm going to switch my screens out. We can go from there. Actually, while we're doing this, skip some room, and I'm going to go ahead. I don't really care that you know the answer. I want you to go ahead and write the second example down. You're probably going to go to another page. On her notes. I saw her notes. She was at the bottom of her page. Other one says the decomposition of NH3 into its elements is a first order reaction with a half-life of 200 dot seconds at room temperature. How long will it take for 1.0 molar in H3 to decompose to 0.625 molar in H3? I bet you're tired of me. What? I'm tired of me. What? But it didn't never let me write last year. And I might just be a complete idiot. It pulled it up on the screen for right now. I don't need power to it right now.
Yeah, that's it should be, yeah. Yeah.
I think it's not plugged in. There or?
Yeah, probably.
Oh, hold on. Riley came through for you. Apparently Riley came through.
Let me check over here real quick.
What?
Let me check this over here because it's shaking out over here.
Just call me Gilbert.
Another one of those things from over there. Like how the Cat 6 goes into that, or Cat 5. You have another one of those?
No, it's one.
That little, you see that brick
What?
right there? That brick right there?
Yeah.
Should have another one of those. There was one over here. I don't remember that. No, it'd be over here.
Oh.
It would be over here, but you didn't take it with you, did you?
No.
That's what you get, right? I'll see if I have an extra. There's some pins for it.
Thank you, sir.
What they now?
Molar. Like molarity concentration. It's inconsequential to the problem right now. Okay. The other than it is the concentration. Okay.
So check your drawers.
Drawers?
Yeah, I want to go through your stuff. So
What?
I want to go through stuff. Oh, shoot, didn't you?
That is the only. That's the only thing I have in here. You want a different classroom? I didn't know if there's no like you exercise for. But if you need it, they took it out. All right, we all got these problems written down? So I'm going to have to paint it up for right now. What? It's hard. It's backwards when you watch the video. Has anyone given Balin the code? Sarah, that's your job. Isn't that or Sarah? Which time? I'm recording, so I can't talk about it right now. All right, so what equation are we going to use for the first one? Read the whole question. Because they both have a rate constant, don't they? They both have K in them. Okay.
Oh, not the rate.
Yeah, there's both equations. We have these two equations that we're dealing with. T1/2 equals ln2 over K. Ln of A over AO equals negative KT. Perfect. So which equation am I to use? Am I to use the ln, the T1/2, or am I using the ln?
T1/2.
Using T1/2. Why?
What's the T1/2?
T1/2 equals ln2 over K. I have. Oh, think of it now.
Wait. So ln 1/2, ln 1/2 is the same as 0.693.
Yes. ln2 is same thing.
So I never have to put ln.
No.
You said 4.
693. So T1/2 equals 0.693 over K.
Is this 600 series? I'm pretty sure.
I wondered what that was. There's a maximum length of cable.
Oh, it's because you got so much of it over there.
Well, I'm saying that's dumb.
You can't get into the ceiling to pull it out.
I'm just talking about, on their end.
Oh, you're talking about for that?
Yeah.
Yeah, no. No, there's not actually. Just depends if you're using, if you don't use the Cat5 over USB, then you have to use power over USB. So it's USB that has power. Yeah, it's just gonna stay right. I don't think this adapter's gonna work.
Kids, like what period? Fourth school? Shouldn't be anybody ready to go check. It's gotta be green. Oh, we're making progress.
Yeah, I think it's because that USB receiver's
Oh, I'm not arguing with that. I do too, but I'm trying to teach my kid, like Balin and Sarah, class. So.
Maybe by Christmas you'll have one of the TVs.
We're getting TVs?
You haven't checked the math rooms?
What?
No, it's a 65-inch 4K TV. That's like a big tablet.
Yeah.
Oh, like in the lecture?
Yeah. Because they
So we
moved
can't,
them.
What?
They moved them. In those classrooms that have projectors, we can't run cabling when you see them. Because if we do, then it looks like that.
Oh,
Yeah, we might have to look for a different adapter. So, yeah, we'll see if I have another one. Of course, it turned out to be.
all right. So we're using because they gave us half-life, didn't they? Then they say the half-life's 25.5 hours. So I'm going to use my T1 half. I'm going to use my T1 half. Where's my mouse? T1 half.
So your T1 half the half-life?
Equals ln2 over k. So do we know the half-life? 25.5. So now we got 25.5 equals, I'm going to go ahead and substitute this in there right now, 0.693 because ln2 is 0.693.
And then K.
In case what we want. Now here's where people go wrong. How do you solve this out? No. Divide what?
No, you divide 25.5 by point. The other way?
Other way around.
Why?
Points, because if you multiply each side by k, you'd have 25.5k equals 0.693. And then so you divide. So 0.693 divided by 25.5 gives you the answer. And what's the answer? You have a calculator.
I know, I'm used to like Reminder or somebody doing it. Yeah, that's why.
Calculator, you need a calculator, Pete. It's gonna make your life so much easier. Now I will say this, you're a CMO student? You're a CMO student? You can rent a graphing calculator from CMO for 20 bucks or 30 bucks.
It is 0.0271766.
Okay, so it's point, I mean, how many significant figures?
Three.
So point what? 0,
0271.
no,
I'm telling you that.
272. Because you need to round to 3. All right, okay, I didn't know that. Now, here's the $1 million question. What are the units? They are the inverse of whatever the half-life units are. So what were the half-life units?
Hours.
No, what's inverse? So inverse, so it's hours, -1. Just like that. Inverse hours.
Well, that's why.
That way, because K, K is not really an object, it's just a constant. So to have all your math work out right, you have to have the correct units on there. So it's just whatever it is in there. Okay, let's do example 2. Tells me the decomposition, NH3 in its first order reaction with the half-life of 200 seconds at room temperature. How long will it take for 1.0 molar NH3 to decompose into 0.625?
So that's the element.
Yes. Riley is correct. Let me find my mouse again. On the total wrong screen.
And how do you know it's
Because it's giving you 2 concentrations.
a lot of numbers?
It's giving you 2 concentrations. Anytime you're dealing with concentrations or percents, you're generally dealing with that one, okay? So, I'm using my ln of A over AO equals negative KT. I'll start plugging in things we know.
So the smaller, whatever,
Mhm.
goes on top.
Yes, ma'am.
And then
ln of what's A?
why don't you just put your number for element?
Because then ln2 is 0.693. Okay, ln2 is 0.693. So what is A? 0.625.
It's always the small one.
The A is always the smaller one. Yes, ma'am. 0.6
One.
over 1 equals, what's my K? Because I'm looking for time, aren't I? So I'm looking for how long? What's my K? No. No. I need a value of K. No. I don't know it, do I?
How can we have two?
That's what no. I'm looking for T, but do I have enough information to find K?
No.
Yes. I know the half-life, don't I? Anytime I know the half-life, I can find K. We just, so the other problem, to find K, so T1/2 equals 0.693 over K. So what said what the half-life, what, 200 seconds? So that's 200 equals 0.6. 00346. I have no idea. So it's 0.00. Okay, equals 0.003 what? What's the whole? It's 3. It ends at 3. 3465. So it ended. Yes, exactly. It's exactly 5. Okay. So yes, ma'am. It would go to the even number. 346. Now, and that would be inverse seconds, wouldn't it? Seconds -1. Now, so now I can go plug this back up in here in this equation, can't I? Negative 0.003. That's a bad 3, 4, 6 times time. You can make an X if you want, but yes. So now how do I solve this out? So you got to put in your calculator first. LN, and then it will automatically open parentheses, okay? Every time you do LN. So LN 0.625 divided by 1, close parentheses, divided by negative 0.00346.
So you take all that and then divide it by negative.
Point. Yeah. If you forget the negative sign, your answer is going to be negative. So you just got to make it positive. Okay. Your answer, you can't have a negative time.
135.
Give me significant figures. 136. Okay.
And that's
What unit?
Okay. Yes, that's the answer, Riley, right? So what unit Seth asked? What was my unit of half-life? Seconds. Our key thing in here is, so your answer will be in seconds, is you have to pay attention, make sure they're not throwing your half-life and your time or your K in different units, okay? Sometimes they'll give some things in minutes and one thing will be in hours, okay? So then you would have to convert it. Does that make sense?
so this unit is seconds.
Mm-hmm.
So 136 seconds.
Uh-huh. Any questions about that? Tomorrow is going to be more difficult, okay? It's going to be the same thing, okay? But tomorrow you're either going to solve for A or AO, okay? And watch the video. We'll go over how to do it. Any questions? Stop share. In the end, I'm sure those people are going to